Alright, so, again, when I have the x value, I can just plug it in.
Wait, hold on. These are the notes we picked up yesterday.
Yes.
Or practice or whatever it is.
Yes. So negative 2 over 2, that gives me negative 1, right?
Mm-hmm.
If I plug in negative 1 over negative
2?
no, because I have a negative in the bottom waiting for me. Okay? Then let me do the other side. So I'm going to go ahead and plot those points. So at negative 1, I go to negative 1. At negative 2, I go to negative 2. Alright, let's go to 1.
What?
I plotted my points.
What's that?
What did I do?
The one at the bottom? What is that? The negative 4?
I did. I went to negative 2, negative 1, negative.
Okay.
Huh?
What's the one under the first one?
A negative 2?
No, the other one.
A negative 1?
Okay.
Alright, so then I can plug in 1. I get the absolute value of 1 over 1 equals 1. The absolute value of 2 over 2 equals 1. So 1 and 1 and 2 and 1. So what do you think based on what's happening? What could keep happening? What if I plug in 3?
It's going to be 1.
What if I plug in 4? 1. What if I plug in 5? What if I plug in 100?
1.
Alright, what about on the other end? What if I plug in negative 3? What if I plug in negative 4? What if I plug in a negative 100?
It's going to be a negative.
Okay, it's still going to be negative 1. So when I read this from left to right, what is the rule for this one? The y equals what?
Negative.
Negative what?
1.
What's the rule for this side?
It's going to be
Y equals?
1.
Okay, so once I have those rules, that means there are restrictions. So when do I equal negative 1?
The 1?
At x what?
Negative 1.
Huh? Not just equal to negative 1, but not greater than. We're going the wrong direction. It would have to be less than or equal to. Remember the bigger a negative number, that means the smaller it is. So what would be the rule for the restriction for this rule?
When x is greater
X
than
is-
or equal to 1.
When x is greater than or equal to 1. So that would be me taking this function, identifying the rule, and setting up restrictions. What this leads into is what we call piecewise functions, which is what today's notes are over.
What are they called?
Piecewise.
Oh, they said like P squad.
Alright, so let's try it again. So I'm going to plug in negative 2. So I plug in negative 2. So negative 2 plus 1 minus the absolute value of negative 2. So negative 2 plus 1 is?
Negative 1.
Negative 1. And the absolute value of negative 2 is?
2.
So I have 1 minus 2 equals?
Negative 3.
Oh, sorry. That's right. It's negative 1 minus 2 equals? Negative 3. So then I'm going to do the next one. So I plug in negative 1. Negative 1 plus 1 is?
0.
Absolute value of negative 1 is?
1.
So 0 minus 1 equals?
1.
I'm going to plug in 0 again. 0 plus 1 is?
1.
The absolute value of 0 is?
0.
So 1 minus 0 is?
1.
I'm going to plug in 1. 1 plus 1 is?
2.
Minus the absolute value of 1, which is?
1.
2 minus 1 is?
1.
So I'm going to plot my points. So I have 0, 1. I have 1, 1. I have negative 1, negative 1. I have negative 2, negative 3. So this function continue. What do you think will happen if I plug in 2? It would be a 1. So let's test it out. So 2 plus 1 is 3. 3 minus 2 is? All right. What do you think will happen over here if I plugged in negative 3? Would it keep going down? If I plugged in negative 3, so negative 3 plus 1 is? -2 minus 3 is -5. So am I not continually decreasing? Alright, so now I have two functions. What do I know about these functions? One is they're both what? Starts with an L. Linear. So that means they both abide by the rule. Y equals mx plus b. This function, do I know what its m and b are? Can I find them though? Why not? Okay. Oh, okay. M is always rise over run. So I rise 2 and I run 1. So what's my slope?
2.
And what's my y-intercept? So my rule is? Okay, what about the rule for this one? My slope is obviously? My slope is? 0. And my y-intercept is? So my rule is? So when does this side happen? When x is what? Less? It's when it's less than or equal to 0. And when does y equals 1 happen? When x is greater than. Ashley, when I'm greater than, that means I'm going to the left, and to the right. Just look at how the arrow is pointing. This tells me that I need to go to the right. So if I'm going to the right of the point, that means I'm greater than the point. If I'm going to the left of the point, that means I'm less than the point. And you can kind of look at these arrows, like see what they're doing? This kind of lets me know that this means I'm to the left of it. This kind of lets me know that I'm to the right of it. See it? You don't see the arrows? Okay, left of it. So this is telling me I am less than whatever that value is. If I am to the right of it, this is telling me what this value is, like to the right of it. So right now I'm to the left of 0, so I'm less than 0. If I'm to the right of 0, then I am greater than 0. Anyone else confused?
Nope, I do.
I don't understand what you did. What is that about an X? Right, no, right there to the right. That.
I'm saying if I'm going to the right, that means I'm greater than, right?
Is that just supposed to be an arrow that you messed up?
She was just doing
No,
that to
I was
show-
showing you, I couldn't draw the arrow over there.
She was trying to show absolute.
Okay, you're going to do 3 for homework.
Okay.
All right?
Is there a backside?
Yep, you're going to do 4 for homework,
3 through.
and we're going to do 5 as a class, and then you're going to do 6 as a homework. Okay? All right, so same thing here. I'm going to plug in and figure out where my points are. So I plug in -5. -5 plus 3 is? Yes, Miles?
Oh, no. You can keep going.
Oh. -2, the absolute value of -2 is?
2.
Okay. -5 minus 3 is? -8. The absolute value of -8 is? So what's 2 minus 8?
6.
All right, that one's done. On to the next one. -3. Plug in -3. -3 plus 3 is? 0. Minus -3 minus 3 is? -6. But when I come out, I am a? So what do I get?
6.
-6.
-6.
Plug in 0. Did I do that already?
No.
Okay. 0 plus 3 is?
3.
0 minus 3 is? When I come out though, I'm gonna become a? So what's 3 minus 3?
Can
Okay.
you get points deducted for writing a pen?
No, it's okay. Alright, 3 plus 3 is? 3 minus 3 is? 5 plus 3 is? 5 minus 3 is? which gives me.
I was running the wrong thing.
So when I do this, I'm going to plot my point. 1, 2, 3, 4, 5. So -5, -6.
I was wondering what you were doing. I was like, I don't know what she's doing.
You got it on the wrong one.
Yeah.
I did that for the first one.
I really need glasses.
This printed really, the graphs printed.
Really badly.
They did. Mine's really hard to see too.
You did a horrible job.
Reprint.
All I did was print.
Very bad.
The printer did a horrible job.
Thank you.
Alright. What does the last one say?
You saw what it looked like
6.
before you gave it to us.
It was the best I had.
I'm 5.
You could have been drawing it on your own paper.
What does the whole thing say? Because I can't see it.
8 minus 2 equals 6.
I can't see it.
Alright, so reading from left to right. What does this y equal?
X, Y equals
What does y equal?
6.
Y equals -6. Hey, you left your binder. What does this y equal? What do I have to find? I need to find my slope and then find my y-intercept. So what's my slope?
2.
So it's rise over run. So I went up. I'm just going to go all the way up 6 and go over 3. 6 divided by 3 is?
2.
And then my intercept is at 0. So do I need to write it?
Nope.
So y equals?
2x.
Okay. And then what's the y here?
6.
So we have our y's. Now we have to find our rules. So when do I equal 6? -6. At what x value? When x is what? We look at the x values. What x value is right here?
Is less than or equal to -3.
There we go. So when x is less than or equal to -3, that's when that happens. When does this happen? When x is what? Not great. We're talking about
When x is greater than or equal to -3 and less
Wouldn't it
than
be negative
or
3
equal
greater
to,
than equal to
less than or
negative?
equal to
So I write it as negative. So when x is greater than -3, right?
it can't
But-
be equal
Less than or equal to 3. We already used the equal.
to? No.
Each interval, they have to correlate. So if I'm equal here, I can't be equal here.
So would that mean, never mind.
So what about my last one? When x is,
I have a question. How did you get that? Like, I don't even.
these are my x values.
It's greater.
This is -3 and this is +3. I start at -3 and I end at +3. So that means I'm in between -3 and +3. So then when I get here, I am, what are these values? They're all to the right, so they are, they're positive. What are they? What's my relationship? They're greater than. So when x is greater than 3.
When do you use the little
Equal to?
chocolate bar?
Oh, chocolate bar? You use the chocolate bar when there's a value. Notice how each one of these is a solid point.
Yeah.
So
I'm
x
gonna
is
use the
greater
entire
than or
time.
equal to?
Okay. What about? Well, I'm talking about that one right here.
This one? The last one?
No, the first two.
Okay, I use it here because from left to right, is there a value at -3? Am I full?
Yeah.
So therefore it's equal. So I already got fed here, so I don't have to worry about that happening again here. So this one's good. So now I gotta worry about here. So I travel along. Is that one full?
Yeah.
Yep, so then I need to make sure I put,
Okay, I just wanted to know why it was why it was on this one or something like that.
yep.
Miss Jones.
Alright, so what are our homework problems?
How
3, 4, 6.
3, 4, and 6,
come
yes.
that one isn't greater than or equal to?
Which one?
The last one, x is greater than.
Because it's a positive.
It is. It's x is greater than 3.
But why isn't it greater than or equal to?
Because we already accounted for it's equal to right here.
Oh.
Y'all like how I move the phone?
No.
No, because what happens when you have to move the laptop in?
I'll just phone floor.
That's ghetto.
The atria, you're.
I think it's a better location. All right. Okay, we're gonna move on to our notes. We are caught up a little bit. Now we're gonna go to actual piecewise functions. Well, more traditional piecewise functions that do not involve absolute value. Not all piecewise functions start off as absolute value functions. This is a true piecewise function. Okay. What a piecewise function is a function composed of different functions, but it's just pieces of those functions. It's not the full function themselves, just pieces of those functions. Got it? Yes.
So like.
So when I look here on this function, I have a piece of a, what's x squared? Parabola. So I have a piece of a parabola. What is this 3?
Linear.
It's a linear, what shape is that? Well, what
A line.
direction is that? A line? What kind of line? Doesn't have a slope, so if I'm a slope of 0,
Horizontal.
a horizontal. So 3 is a horizontal line. So I have a piece of a parabola, a piece of a horizontal line, and then what's my last thing? What's 6 minus x? No, you're fine. Okay. Huh? What's 6 minus x?
6 minus x.
Yeah, what function is that?
Regular letter?
What, regular linear? Well, I don't know what that means, but it's a decreasing linear, okay? Why is it decreasing? Because it's a negative x. My slope is negative. Okay, so I have pieces of other functions. Again, we said that this is a quadratic. We said that this is a horizontal line. And we said that this is a decreasing line, right? So altogether, these pieces make up my new function. What? Okay.
What's the middle say?
Horizontal. It says hori, but horizontal is what it stands for.
You should have just added a z. It made so much sense.
It didn't work out.
Well,
All right, so the first thing is I need to identify my breaking points. My breaking points are determined by my intervals. Well, I only have 1. What's my breaking point? 1. So that acts as kind of like my imaginary line. That helps.
It's not good to use your ones.
I did it on purpose because it's supposed to be invisible.
Oh.
so.
What does that say on top?
Quadratic, quad,
Quad on the bottom?
decreasing.
I didn't really need class.
Why don't you just scoot your desk up?
Should I do dotted lines?
I feel
or
weird.
just not?
Yeah. I would do a dotted line.
Okay.
All right, so we're going to start off with the x squared. So x squared only from left to right is going to stop where? At the 1. So if I plug 1 to x squared, what do I get? 1. Am I included or not included here? Not included. So what do I use?
Open circle.
An open circle. Whoever said that while yawning. So I'm going to have an open circle there because I'm not included. Remember?
So I gotta do a dotted line all the way down?
Where?
At 1, 1.
At 1, 1, I have a open circle. Remember, if you had me last year, I talked about the chocolate bars. Okay? So last year we talked about chocolate bars. If I am hungry, if my stomach is empty, I am hungry because I haven't eaten anything, right? If my stomach is full, that's because I had a yummy, yummy chocolate bar.
Right.
Okay? You are so crazy.
Why?
Where did you get 1 1 from?
I got 1, 1. What is x squared? What is 1 squared?
So we leave the 1, 1.
1, 1. So therefore at 1, 1, it's a open circle. I'm hungry because I have no chocolate bar. Okay? Now, x, I forgot about equal. Equal is super full because it had how many chocolate bars?
Too many.
2 of them. Okay? So that means, why am I dumb?
There ain't no such thing as super cool.
Okay.
Okay? So we know here I'm going to have a closed circle, right? So this should be an open circle, closed circle, open circle. Open? I don't know. It just happened. All right, so now let me finish making this parabola. So what is 0 squared?
0.
What is negative 1 squared? What is negative 2 squared? Actually, all I'm doing is plotting x squared. I'm just plotting x squared.
The dotted one was the middle. I mean, the first one.
Yes, it's only this one because this is my boundary line. This is where I
Which one is
define
that
it.
for? The middle one?
I've only done x squared.
But how are you getting the
I'm plugging in x values to figure out where I go.
okay, I'm sorry.
Yeah, I'm just plugging in x values.
3.
Negative 3 squared is. Can I go anymore?
No.
No, so I'm just gonna connect.
Aren't you a nice person?
Don't stop. Quadratic is done.
Right.
Wait, why doesn't it go that way?
Because I have this line that stops me. It says that my function is only less than 1. That means it goes to the left of that value.
I don't get it, but okay.
Can you just try to have an open mind for me? And like be willing to try it. Just give me a little bit more. Okay?
Okay, hold on.
Wait. Oh, okay. I messed up.
Give me a minute. Okay, where did the dotted line come from again?
Okay, the dotted line is my interval. It's what's defining where I start and where I stop. Okay, so this dotted line is at 1.
Okay, so whenever I do this, it's always going to be the same number, right?
It can be, yeah, it's gonna, but this one has 2, so when we get there, you'll see one with more than 1.
Okay, so it can have more than one dot.
I think you guys are always trying to look for a rule, like a cheating way out of doing something.
Possibly.
I think don't try to, like, everything's connected, but wait until you see why they're connected.
So like,
I think
on
we're
the
all
next one, if there's 2,
specific reason why they came up with that.
Right.
so on the next one, if there's 2, there can be 2 dotted lines, right?
Yes,
Okay, and can anything be in between those? Or
yes.
Okay.
That's why you have,
What does it mean if it's in between?
that's when you have the X in the middle.
Okay.
Hey, girl.
I haven't seen it. Alright, so back to what I was going with this. Alright, so now we're on to the middle line. So at the middle one, it's just a horizontal line, right? But it only has a value where? At 1. So at x equals 1, what is it?
3.
So I go to x equals 1 and I plot,
3.
and I'm full, so I just plot a.
Well, I wish I was full. I'm so full.
Wait, which one is one? This is the second one.
Yes. So we've done horizontal. Now we just did. No, we've completed quadratic, and we just did horizontal.
So that's what it just.
That's it. There's no other rule for it. It says at x equals 1, I am 3.
So the next one.
So now the next one is 6 minus x. So where does 6 minus x? If I plug in 1 there, where do I lie?
5.
5. So here, am I open or closed at 5?
Open.
All right. So now I can figure out the rest. So if I plug in,
Wait. Because we got 1, 5.
I go to at 1. I am 5. This is my x.
I thought you would go to 6.
6 is right here. I didn't plug in 6. I go to where I plugged in. So if I plug in 2, I'm going to go to 2. I plug in 3, I'm going to go to 3. Okay? Just so that we can... Someone hid your phone in the dry eraser basket. In the dry eraser basket.
Try to check somebody who ever had it.
Alright, so this tells me I can just go ahead and plug in x equals 6 because that's going to take me where? 0. So I know I'm going to end up down here and I can just connect those dots. Instead of doing every line in between, And that's my full function.
Oh, it's supposed to be open.
You are so
Okay, so what'd you say, little code?
I see you already.
So it's the x is 1, right? Like
What do you mean?
This x is 1, right?
6 minus x.
Is 1, right?
No, this is saying at x for 6 minus 1, I'm an open circle. There's no value there.
That's why I
But
said
6 minus 1 is 5 within open circle.
Tired of this
And
crap.
then it just goes down like a regular function.
Then it goes down like a regular function because I could just do my slope, right? I could go down and to the right, down and to the right, down and to the right, down and to the right,
So
down and
it's
to
just
the
like
right.
a regular.
It's just a linear function.
Is the x equals 1 always gonna be in the middle of?
Knowledge.
It depends on where it falls in the piecewise function.
Can you got a y-intercept at 6?
Yes, but I don't get there because I have
X-intercept.
Yes, I have an x-intercept at 6, but I also have a y-intercept at 6, but I don't get there because I have that breaking point, that boundary line.
So that 6 was that 6 from over there?
This 6?
Yeah.
No, this 6 was just an x value that I plugged in to see where my function was heading. So I plugged in x equals 6 into this, and I got 6 minus 6 is 0. So at 6, I go to 0.
Okay.
I got 5 from plugging in 1, and 6 minus 1 is 5, and that's why at 1, I have an open circle at
You
5.
got a line and you're always in the top. With the starting there.
No. Oh, from the dotted line? Yes. It's either my starting or my ending point for my
I'm
function.
only confused on one thing.
Okay?
Why there is no line for the second one.
For the second one,
Yeah.
because it's a horizontal line and it doesn't go anywhere but to x. It doesn't expand between anything. It just says at x, this is my value. And what this allows for me to do is, this is a continuous function because for every value, there is a y. So for every x value, there is a y value. So therefore, I'm a continuous function and I continue from negative infinity to positive infinity.
Also, the x is just there to continue it. I mean, that one. That one is dark.
It's not just there to continue it, but it's just what this function is made of. Everything in the real world is based on piecewise function because nothing is we're not consistent. So there, at one moment we may be doing one thing, then at another moment we may be doing this function, and at another moment we may be doing this function. So because of their lack of consistency, that is why piecewise functions are used to model real world situations.
So this is all connected.
Yes, it's all connected. It is connected. I just did it all in different colors.
So,
Was it all separate or was it all?
No, it's all connected. Remember, this is an invisible line.
Okay, question. How did you find your domain?
How did I find my domain? I look and going all the way to the left, my x is going forever. And going all the way to the right, my x is still going on forever. So my domain is from negative infinity to.
And range is the same, right?
This, right?
So my range would be the same. So my range is as I look at the bottom, my y's are going on forever. As I look at the top, my y's are going on forever. So my range is.
Good job. I know you just heard what Paul just called me. It was so inappropriate, like.
I'm sorry. I would like y'all to know that if you're still not understanding, I just explained a whole lot.
yeah,
And I hope you were listening. And if you ask me a question that pertains to what I just explained, I'm going to suggest you just go watch the video for the time where you weren't listening. Thank you for the disrespect.
Wait, are you recording right now?
Yep.
So are you gonna cut that out?
Nope.
Ooh.
If you turn up the volume.
Steven.
Okay? So now I'm going to go into the next problem. So at the next one, I don't think we're going to be able to get to the back. I feel like you're going to ask a lot of questions. So I'm going to look at my intervals. So my intervals are -2 and 2, +2. So I'm going to go ahead and put in my invisible boundary lines, my little breaking point.
Oh, wait, so why is it called the breaking point?
It breaks my function into parts.
Dang, Bill.
Do we have to do this all the time?
Yes.
If you don't need them, you don't need them, but I am doing it for notes purpose.
Okay.
No.
Actually, don't try to
I was interested before.
Okay, so then once I have that, now I can start focusing on the function. Looking at my first function, I know I have a negative linear function, right? Which means it's decreasing. Here, I know I have a reflected over the y-axis radical, which is square root function. So my function looks something like this, because it was reflected over the y-axis.
What's that?
Okay.
What is that?
I don't see how you
Negative linear.
So what should I write for?
I'm about to. Okay. So it's a square root function that's been reflected. Why do I know that? Because I know my square root functions, because we just learned them. Parent function of square root. It starts here, does something like that. When I have a negative on the inside, it's going to cause me to do something like that. Alright, I have a positive square root function. So my function is going to look like that. Okay, so there's a lot that can be told from just looking at the function itself. And then I start. So I'm starting at negative 2x minus 1. And this happens when x is less than or equal to negative 2. So the first thing I do is I'm going to plug in negative 2. So I plug in negative 2. I get negative 2 times negative 2 is
4.
And 4 minus 1 is
3.
So at negative 2, I have a closed circle at 3. Why is it closed?
Because it's full.
Because it's full. I have that equal. And then now I can find out other values. So I can plug in negative 3, or I can use my slope. So I know my slope is negative 2 over 1. So that means I can go up 2 and left 1, right? So I can go up 2, 1, 2, left 1. Up 2, left 1, up 2, left 1, up 2, left 1. And this shows me the path that my function is taking.
I feel like this one was a little bit easy.
It wasn't at all. Sorry.
It wasn't easy?
Same stuff.
I just looked at it easy.
Maybe because you got quiet.
No.
Alright, square root. So that one's done. So now I'm going to the square root function. So the first thing I'm going to plug in is negative 2. So I'm going to plug in negative 2. 2 minus negative 2 is?
0.
2 minus negative 2 is? 4. Square root of 4 is? 2. So at negative 2 I go to? Am I open or closed there? Open, because right here, does this one have a bar underneath? No. So I'm open. And then I'm going to test my end value. Where do I end at? So I plug that in. So I have 2 minus 2 is? 0. And the square root of 0 is? 0. So on my other breaking point, I am 0. And it's a closed circle because it's? So I can just connect those. Is that my shape?
No.
It's my reflected?
Yep.
Okay.
Why is it curved?
Because it's a square root function. It's not a linear function.
Wait, you have to.
It's curved.
I don't understand how you manipulate it.
Because I plugged in 2, and 2 minus 2 is 0. And so at x equals 2, the value is 0. And then these are part of the same function, so they are connected. Yay, nay, maybe so.
Maybe so.
I'll take maybe so for now. Alright, so then we have 2. So I'm going to plug the 2 in. And what? I plugged it into the wrong spots. I'm going to plug this 2 in, and I get 0. Currently, I'm already full there, right?
Yes.
So guess what? That still counts as me being full. I'm still full there.
Even if you don't have a chocolate bar?
Even if I don't, because I already ate one.
Wait, what?
I already ate one.
Wait.
I am still full here because what happened here? I already ate one.
So we have to on the same line if the first one was
Huh?
stay full?
Yes. So if I'm already full once, I'm going to stay full because I'm trying to be conscious of my weight.
But what if you're hungry
I'm
though?
not.
So if one was
Hold on, Ashley was trying to answer. Ashley.
Okay. Just explain it again to the kids. You really just.
All right, guys, like not using chocolate bar analogy. If I'm here, if I already have a value here, if I already exist here, because I exist with this function, I don't exist with this function, doesn't make me invisible. I've already been acknowledged. I came first. I'm here, I exist.
So
there is already a value for x equals
So you
2.
just put another one on top.
So it would just be another full bar. It still will remain full because that value still exists there.
like people.
Okay? And now I have to figure out what happens next. So as I go further next, the easy thing is to try to put a number underneath the square that will make this a perfect square. So a good number to use would be 6 because that gives me 4. Square root of 4 is? So that means at 6 I am at 2.
Does it
And I
matter?
can just connect those
Is it?
dots.
Does it matter?
It doesn't matter what number you put in. It just makes it easier to know which number. Because personally, I don't know what the square root of 2 is off the top of my head all the time. I don't know what the square root of 3 is off the top of my head all the time. I don't know what the square root of 7 is off the top of my head. So why not find a number that I can plug in
Alright.
and know what its perfect square is?
Question. Alright, let's say, for example, just by looking at it, I don't know what it is. Like, is that gonna be a problem for me to figure out?
The shape? What do you mean you don't know what it is?
The square root of something. Right?
Like, no.
Oh.
I'm talking about earlier we said it's a negative linear and it's a I don't know what and a square root function.
So if I don't know the shape, that is okay. Me knowing the shape just helps me validate what I'm doing. Because I know the shape, I know what direction I'm curving things. I know what direction I'm heading. And if you don't know the shape, that's when you would just plug in the values to figure out and then connect those dots.
Okay. So it's not a big deal at the moment.
No. All right. So my domain would be all real numbers. What about my range though?
0 to infinity.
And I have a value at 0, right?
Okay, got it.